So the first of these new forms we're going to look at is when you take a 0 and multiply it by infinity. This one is the most kind of direct application of L'Hopital's rule without necessarily needing to do a lot of other stuff. So we look at an example. We have x times the natural log of x, and we're trying to plug in things that are slightly bigger than 0. But if we plug in 0 into x, we get 0. And the natural log function looks something like this. So when you try to plug in things that are close to 0 for the natural log, you get these really big negative infinite answers. So we have this 0 times this infinity thing. All right, so it means we want to try to use L'Hopital's rule in some way because this is one of our indeterminate forms. So how are we going to do this? Basically, we're just going to rewrite this limit in a different way. I'm going to keep the natural log here. That's when I try to plug 0 into that, it's infinity. I'm going to rewrite this on the bottom. Why is this the same thing as before? Well, if I take 1 over x, I can multiply the top and bottom of this function by x over x, and that gives me x, because the bottom cancels out. So it turns out this x here, I can rewrite, move it to the bottom of the fraction, and make it a 1 over x. And then if I try to plug in 0 into 1 over x, all right, as x goes to 0 for 1 over x, that goes to 0. Goes to infinity. 1 divided by a really small number is going to give me a really big number. So now I have this natural log of x is trying to go to negative infinity. 1 over x is trying to go to positive infinity. And that's what I can use L'Hopital's rule. I have this infinity over this infinity. So now my limit, instead of using these two functions, I take the derivatives. The natural log of x is 1 over x. The derivative of 1 over x, again, with a lot of times with 1 over x, we rewrite it as x to the negative 1. So the derivative of that is going to be negative x to the negative 2, using that power rule. And just to kind of see what's going on, I'm going to rewrite a couple things. I guess remember, a negative exponent is just the fraction version of that, and I can multiply top and bottom of this by x squared. And some things are going to cancel out, and this is going to become the limit as x approaches 0. On the bottom, those x squareds cancel. On the top, one of them cancels, so I get negative x. And now I can just plug in 0. Negative 0 is my answer, which is just 0. So really, this whole thing is just a L'Hopital's problem. If this was a problem I gave you in the previous section, we were just using L'Hopital's, you would do exactly all of this. The only difference is we just do this one step of rewriting this x on the bottom as 1 over x, and then it allows me to use L'Hopital's rule. I will do one more example using this 0 times infinity thing. If I plug in infinity to x, this is going to be infinity. We saw before 1 over infinity. If I'm trying to plug in infinity here, 1 over infinity is going to be 0, and sine of 0 equals 0. So this left-hand side is going to infinity, and the right-hand side, let me just get rid of that. The right-hand side is going to 0. So it's another one of the infinity times 0 indeterminate forms. So we're going to do something very similar to what we did in the last problem. Is rewrite this x on the bottom of the fraction as 1 over x. And now if I plug infinity to the top, I get 0. If I plug infinity to the bottom, I get 0. So it's an indeterminate form, and I can use L'Hopital's rule. So I'm going to take the derivative of the top, cosine of 1 over x, times the derivative of 1 over x, which we saw in the last slide was that. On the bottom, it's just the derivative of 1 over x. And this one simplifies kind of nicely because these two things just completely cancel out. Oops, I keep writing 0, but that's infinity of 1 over x. And again, as x goes to infinity, 1 over x goes to 0. So this is just cosine of 0, and that's 1. All right, so really this indeterminate form, when you have a 0 times infinity and you're trying to find the limit, it's really just this one trick of taking your x and rewriting the bottom of your fraction as 1 over x. Then you use L'Hopital's rule just like you did before. Some things cancel out, and then you can plug in what you want to plug in.